Now that I've got Pyshark and Pyshark installed, I could run Pyshark directly and capture packets. But that's not actually what we want to do. But notice here we're seeing in real time that we are able to capture spanning tree packets. Here's EIGRP, here's OSPF. So I am actually capturing packets off the network. But what I want to do is capture packets and write that to a file. So I'm going to write that to this pcap file, tshark1.pcap. Now, I want to leave this for a while so that packets are captured. But to generate additional traffic, what I can do on my router, for example, is ping some addresses. So I could ping, as an example, 192.168 and 122. And what I'll do here is ping the broadcast address 255. And those packets will be captured. I could ping a multicast address as an example, and those packets will be captured. So various packets are being captured by the Pyshark application on the Ubuntu PC. I could, as an example, reset my OSPF process to generate some OSPF updates. But I mean, we've captured about 60 packets already, so what I'll do is stop that capture. So now that I've got my Pyshark pcap file on my local directory, so notice I've got that file on my Ubuntu host. Now that I've captured packets off the network, I can open that up with Pyshark. Now, in the first example, I'm going to show you commands directly from within Python 3, and then I'll create a script. So for the moment, I just want to show you the commands. And the first thing I'm going to do is import Pyshark. And then I'm going to say cap. This could be any name. This is just a variable. Pyshark file capture. And the file I want to capture is tshark1.pcap. That's the Wireshark capture file. Cap shows me the file that I'm using. And now I can do all kinds of things. Now remember, this is from within Python. So if I want to look at the first packet, there you go. Notice we captured a spanning tree packet. Again, this is running within Python. I can see the length of the packet. I can see the Ethernet header. So I'll make this bigger. Source MAC address, destination MAC address. I can see that this is a spanning tree BPDU. I can see who the root is. Notice there's root identifier, priority MAC address. So root bridge priority is this. Forward delay is this. Hello time is this. Root bridge system ID is this. Bridge priority is this, so forth and so on. I could look at packet 1 as an example. This is an EIGRP packet. So layer 2 Ethernet header. Source MAC address, destination MAC address. This is the multicast MAC address at layer 2 for IP version 4. Notice 10. That's the multicast address used for EIGRP. Ether type is IPv4. So at layer 3 we have an IP header, IP version 4. DSCP is set to 6, very important traffic. Source IP address is this. Protocol number is 88, EIGRP. So notice at the higher layers we have EIGRP. We can see the K values. Now this output is all over the place, but notice K1, K2, K3, K4, K5, K6. We can see software version. We can see the autonomous system number, 100. If we have a look at packet 2, we can see that this is a spanning tree update once again. So spanning tree BPDU. What about cap 3, spanning tree, cap 4? This is EIGRP again, 5. Spanning tree, 6. OSPF. So 6 is OSPF. Layer 2 header, layer 3 header. Notice protocol number is 89. Here's OSPF. Now, please remember, this is running within Python. I'm showing you some basics now, but later on I'll show you how to script stuff. So as an example, if we looked at packet 1 and we use the show option, so print, and I don't actually need to use print from within Python, I can just do it this way. So cap1 show. And I actually want to do it this way. Notice here's my EIGRP packet in pretty format. So Ethernet header, IP header, EIGRP. Let's look at 6. 6 is OSPF if I remember correctly. Yes, it is. So here's our OSPF output. Again, this is all being used from within Python. I'm running this output in Python. Now you might say, okay, but this doesn't really help me. Notice what you could do is I could say, okay, print cap1, which was EIGRP if I remember right, IP. Notice this is the IP header. Or I could say only show me the EIGRP information. So once again, this is everything. Make some spaces here. So this is everything. Notice print cap1. This is everything. But what I could do is just look at the IP header. Or just look at the EIGRP header. Or, taking this a step further, look at the autonomous system number. And that should be an S. So AS number. AS number is 100. So rather than trying to dig through the information, this makes it much easier. This application, Pyshark, allows me to look at specific details. I could, as an example, look at the parameter K1. What's K1 set to? It's 1. K2 set to 0. K3 set to 1. K4 is set to 0. K5 is 0. K6 is 0. The moral of the story is I can burrow into the capture and get information and then store that in a variable. So I could say EIGRP AS equals that. And let's get rid of the bracket. So if I just look at EIGRP AS, that's what it is. And then I could do something with that in my programming. Commands such as dir work here, so I could look at a specific packet. Let's look at the EIGRP one again. And I can see all kinds of options available for that packet. So I could, as an example, print IP. And I'm doing that wrong. It should be IP like this. So there's the IP header once again. So let's do that dir again. So a lot of options available in this application. Notice, looking at layers, we've got an Ethernet layer, IP layer, and EIGRP layer. We can look at the Ethernet header. So just look at ETH. There's our Ethernet header. We can see source MAC address, destination MAC address. A lot of options available here. Okay, so that was basic Python. Let's see if we can create a script, however, rather than doing it directly live coding in Python. Now, I have seen this error come up. Now, Stack Overflow is a great place to go and look for help if you're having problems with programming. Someone else has had this problem as well, where this message displays. So notice, as an example, they're having these errors, very similar to me over here. And the answer is to upgrade the versions of software. This was actually a bug in one of the versions of software. Now, I'm not going to worry too much about that because it doesn't really affect what we're doing here. So I'm going to clear the screen, and what I'm going to do now is create a Python script.